Good morning. Uh-oh. Camera problem. There we go. Come on. You can do it. Maybe. That's not good. Okay, that's weird. uh, now if I switch back, is it, yeah, it still works. Wow. That is so, that is so annoying. Okay, so I made the cliched mistake of updating OBS right before the stream started. Because of course, when I started OBS, like, oh hey, there's a new version. I'm like, okay, cool. I'll take a new version. I mean, OBS has its little issues here and there, but by and large, you know, I would say it's been pretty stable. But yeah, I'm an idiot. I should never have done that. Because, yeah, shit happens. And they broke the UI, at least on OS 10, for like your sources. So, and I don't know why did they think that it was a good idea to move the little eye icon and the lock to the right instead of leaving it on the left? Like, it was fine where it was at. Seriously. Okay, I think I've got it looking halfway decent again, maybe. Let's take a look. Yep, that looks better. And I don't know, are we getting any audio here? Can you all hear me? Looks like you should be able to, but all right, I'm gonna assume that I've got it all fixed. Excuse me. All right. Okay. Today is the 21st of August, 2018. This is the nybbles.io daily programming stream. My name is Jeff. I write code every day, give or take, and I stream it here on Twitch Monday through Friday. I was out yesterday because yesterday was a perfect storm of shit, which I might talk a little bit about. But I'm working on Basecode, which is a new programming language that I'm designing. Specifically, I'm working on the Bootstrap compiler, which is written in C++. And let's see, yesterday I really did not, I literally got like 2 hours free, which really sucked. And I wrote a little bit of code, not much, but I got something done. So I'll consider it a win for the day. I got the, well, okay, so let me back up. I was working on the cast operator. And so cast, I don't remember where I left off, so I guess I'll just cover everything again here. Cast, we have numeric casts, and we'll have pointer casts, and that's probably about it. Although, you know, never say never. There might be a case where we would need to cast some other type in some situation. I can't think of it right now, but I wrote down some rules about what happens with numeric casts, right? So between two integers the same size as a no-op, a larger to smaller is a truncate, a smaller to larger is either a zero extend if it's unsigned or a sign extend if it's signed. From float to integer, we'll round the float toward zero, which I'm not doing right now, but we'll get into that. And also implicitly here, convert the float into an integer. Casting from an integer to a float would produce the floating point representation of that same integer. Casting from a float to a double is lossless. It just becomes a double. Although there's some niggles here, which we'll talk about. There's some details. Casting from an F64 to an F32 produces the closest possible value with rounding. Casting from a Boolean to an integer yields either 1 or 0. Casting any integer whose least significant bit is set would yield true, otherwise false, because the least significant bit is 1. So if it's 1, it's true. Pointer casts, haven't even gotten into that. Although realistically, pointer casts are really just numeric casts. They're just integer casts. About the only thing we probably really would be doing differently here is like no signed. Everything would need to be unsigned. Anyway, I wrote a bunch of code, right, that figures out the type of the expression that we're casting from and what type we're casting to. And once I figured all that out, we do our fairly typical emit stuff here for getting things into the right registers. And then finally, we have a mode, right? We're going to do an integer truncate, which means we're going to from a larger to a smaller integer. We're going to do an integer sign extend, which means we're going from a smaller signed integer to a larger signed integer. We're going to do an integer 0 extend, which means we're going from a smaller unsigned to a larger unsigned. And I added 2 new opcodes here, move S and move Z. Move S is for sign extension, move Z is for 0 extend. And these appear to work correctly. I haven't tested them exhaustively, but they look mostly correct. Then for floats, we have float extend, so this would be F32 to F64. We have float truncate, that'd be F64 to F32. We have float to integer and integer to float. Now, so here's where there's a couple things I gotta fix. One is, it has nothing to do with casting at all. The way the interpreter is handling, hey, super circuits. Hopefully all you guys can hear me. I made the mistake of upgrading OBS this morning. That was a bad idea. What was I going to say? I don't know. Hey, super circuits, can you hear me? I don't know if audio is. I'm assuming it's working okay, but I don't know. I had OBS issues this morning. Okay, good. Well, that's positive. All right. So, where am I going with this? Oh, right. So, floats. Let's talk about floating point. So integers are easy, right? Because really, the different types of integers are just how many bits, right, are in the integer, make up the integer type. The only special case, right, is the sign bit, which is pretty easy to handle. Other than that, you can take a 64-bit integer and truncate it. You can take a smaller integer and expand it, widen it, and there's no format, right, inside of an integer. Again, with the exception of the sign bit for 2's complement, there's nothing inside the mask that has any special meaning. Floats don't work that way, unfortunately. I mean, technically speaking, a 64-bit float is, IEEE 754 is the same type, it's just larger, but the bits, because the bits are subdivided, they have special meaning. It's not, you can't just easily widen or truncate floats. There's actually a conversion that has to take place, which really sucks. And so there's actually a bug, not here, it's in the interpreter, that I have to fix first. Hence the part deux. And that is the way that I'm handling loading and storing, hey Slayer Dart, floats is not right. Got kicked out of the bedroom. I'm in my bedroom. I don't follow. Sorry. Oh, the bed? Oh yeah, well that was one of many things part of the shit show yesterday. Oh my God. So I have no idea what happened yesterday. It was Sunday, actually, late Sunday. I live in the Southwest United States. Wow, that's loud. Holy shit. Why is that so loud? Don't ever upgrade OBS. Don't ever upgrade OBS. Why was that so? Hopefully that wasn't that loud for you guys. Hopefully it was just me. What was I going to say? Oh yeah. So it's very hot here during the summer. Typically, okay, good. I can suffer through the loud noise until I figure out where it's coming from. People run their air conditioners pretty much 24/7 here when the summer starts. I don't know. I don't know if they were having power problems or what, but I kid you not. Like, I heard this crackling, popping sound, and I smelled what I thought was solder. Of course, it was, just wasn't me doing it. It was something melting. My bed, has a built-in pump, has a built-in little control unit that keeps it at the level I set it at, right? And it's a handy little feature. And the pump that's built into the bed is very fast. And because it has a feedback loop, it knows exactly when it's reached the correct internal pressure, and it stops and all that great stuff. But not after that, because I go over and the control unit on the bed is melting and it's blinking. The LEDs inside are blinking. I'm like, oh, you gotta be kidding me. And so, yeah, I can't deflate the bed because the control unit's dead. Now, I will give the manufacturer, this is an Intex. I've had other manufacturers' air beds. This one at least has like an emergency valve, a one-way valve. So if you have an old-fashioned pump, external pump, you can, inflate or deflate it that way. The problem is it's very slow. Like insanely slow, and the external pump is very loud. So I ordered a replacement bed, this time not an air bed. I can deflate it. It's just I gotta wait until my new bed shows up before I deflate it, because it would take me like 4 hours to reinflate it, and I don't want to do that. So I ordered a new bed, paid extra to get it here, and Then I got stuck in customs. Then it turns out, I'm like, where's my continuous power for my camera? Right? So I go check on that. That's stuck in customs. So I'm like, what the hell? So then I'm start scratching my head. I'm thinking, damn it, I hope that this isn't like a trend here with Amazon where everything that's coming from China now is going to get stuck in customs because Trump, I don't know, tariffs. See you later, Weeson 3000. And, but the fun doesn't stop there. It gets better. So yesterday, I wake up, I have no voice. So Sunday, I was losing my voice. And we've had a lot of smoke in the atmosphere here because of the wildfires. We have wildfires here in Utah. Some of them are actually quite close to where I'm at, but the smoke is blowing northward for the most part. It's blowing away from where I'm at. But the California wildfires are just literally like covering Utah. The north is much worse off. So like when I say north, I mean like Salt Lake and that area, the Wasatch Front area. But we get our fair share of it down here too. And Sunday was just horrible. I mean, it was everywhere. And yeah, so I started losing my voice, and then on Monday it was pretty much gone. Then I want to make coffee Monday, and so I go into my coffee closet, and my Keurig is blinking, and it got whacked by the electrical whatever it was that happened. Thankfully, those two things were the only things that appear to have been affected. Almost everything else I have here is on a UPS or some kind of grounded circuit, specialized, surge suppression circuit. But the coffee maker is 1400 watt. It was insane. So it just got plugged right into the mains. And my bed was on a power strip, but that power strip, I think, wasn't capable of suppressing whatever surge. Now, ironically, I use a CPAP. Now, that's durable medical equipment, which is probably why it survived. It survived, right? So I'm guessing because it's durable medical equipment, they have additional bypass capacitors and some extra resistors right on the power supply. But hopefully that doesn't clonk out. It seems to be okay. But anyway, yeah, it was loads of fun. So then I had to get a new coffee maker, and I did see something really cool though. Well, cool for a nerd, I guess. Here, let me plug in my phone, because that's where the picture's at. And I'm sure others probably have seen stuff like this, but it's like the first time I've seen it so common, I guess. High volume, I don't know. I swear, Apple at one point had a fairly reasonable, yes, then they do this, do you trust this computer? But to do that, then I have to get my tablet out. I got to get a different device, because then I have to approve it not from the same device, from a different device. And I can't approve it from the computer. That doesn't work. All right. Let's do it this way. Yes, send it to me. Yes, it has an empty subject because I'm sending it to myself. Come on. There it goes. Okay. Rotate. So I was at Best Buy, okay, because I had to buy a new coffee maker. So I noticed, at first I didn't really pay any attention to it because I just thought, oh, okay, those are the pricing stickers, right? But then it dawned on me, no, wait, that's actually a little display. And sure enough, this is a little display. And it can be programmed at the point, right, with a device, but it's on the network. And so they literally can change all the labels on the fly. And the inventory is live. So, if it says it's in stock, that's based on whatever the computer actually says is the case. So that's pretty cool, I thought. Now again, I'm sure other retailers might be using something like this, but it's the first time I ever saw it. I've ever personally seen it, right, in a live setting where, there were so many of them, right? And they had different sizes. So they had the larger ones, and then they had smaller ones, and they even had one model that was just literally like one line type deal. So even a little smaller than this. But I thought that was pretty slick. So anyway, yeah, probably. Although the resolution on these is not that great. But for what they do, as a... Yeah, this is Best Buy. Best Buy in the US. I was talking to one of the managers because I asked him, I'm like, hey, are those RFID? Do they automatically detect the product they're nearby? Because that would be really, sweet. He's like, no, they're not quite that fancy. They program them. They're all laid out by shelves and stuff. Anyway, I thought, okay, that's pretty cool. But anyway, he was telling me that Best Buy prints out, that particular store was printing out 500,000 pricing tags per week because of specials and price changes and errors and everything. Now they don't have to do that anymore. And the other thing too is it's much easier now. They have barcoding and everything all built in. Plus there's this there's solar power here, but there's also a little IR, I think, interface. I looked at it a little bit. They have a device, they can stand a couple feet from them and they can interface with them fairly quickly. I thought it was interesting, right? So to me, of course, my cynical brain, where does my brain go with this? So I asked him, I'm like, all right, well, how much labor did this save you? And he just said, well, we were spending easily 16 hours a week just changing labels, right? Now, obviously, it's not all at once. That's 16 hours spread over a 7-day period, but still, that's a lot of time. And then I said, well, okay, what about everything else? What about changing prices? What about, rotating inventory? He's like, oh, you could easily add another 30 hours, to the 16-hour number for that. Plus, whenever, I don't know if any of you ever worked in a large retailer, but they frequently have inventory audits because people steal things. And it's not uncommon, right, to spend an extra maybe 12 to 24 hours once a month doing a full inventory audit. But with this system, he was telling me that their inventory audit only takes 2 hours a month, which is like, wow. So there, my cynical mind's like, okay, here's an example of automation it's not a robot. It's not the Terminator, right? He was telling me these don't cost that much. He said the larger ones they can get them under $4 in volume, and the smaller ones, he was telling me that they're just under $2 in volume. So, if you think about it, and that's just it. This was what I was going to say, right? What, 10, 12 years ago when I worked at Redbox, all this stuff was way too expensive, right? Like none of it was practical. Because you would think, okay, you have a DVD kiosk renting movies and returning them. Why don't you just, use RFID in the box and it's a piece of cake? But it was just way too expensive. And, little displays like this there probably were prototypes. I mean, Sony probably had their e-ink thing, right? But again, just not at the point where it would have been practical to use it for anything. But, 10 years go by and they perfect the manufacturing process on these, they perfect the solar power on these, and the solar cells probably needed to evolve just enough, right, to be able to get to this point. And, yeah, I mean, here's an example of automation that is going to impact people. And more stuff like this is going to happen. And these cost savings, these time savings and cost savings, labor savings, are going to add up, right? So not everything is really super flashy. Yeah, there you go. Yeah. I use Sea Lion. That's the IDE I use. No, I don't want to copy. Anyway, I thought that was kind of interesting. And unfortunately, I don't have anything to demo on this, but let's just say, because I used to technically work for McDonald's, because they owned Redbox when I started there, I got to meet a lot of people in corporate. And let's just say I know somebody there, and, they were telling me that the days of parking a workplace is going to be over pretty soon. To which I say hallelujah. But yeah, there goes a bunch of jobs right there. Sorry, I had to try to get the full effect, It had to be really loud and it had to be muffled, and yeah. He wouldn't tell me the exact details. But I gleaned from the conversation that it's going to be a combination of the touchscreen interface and voice recognition. They use kiosks in the store. Yeah, it's not exclusive because they're still kind of working out the problems. And that was a point that I made. I'm like, the kiosks that you guys have in the store aren't really that good. And he's like, oh yeah, that was, a third party, and that was really for testing. So, yeah, change is a coming. Do you have a degree in computer science? Only in my head. No, I never went to university. Never got credentialed. But at least in my own mind, I have a pretty good run of experience that would be the equivalent of a computer science degree or two. What was I going to do? Oh, yeah. Floats. So first, 64-bit floats work. Hey, Cyanox. Oh, cool. I'll have to go look it up. Woohoo! Unknown exception. All right. Well, I guess it all depends on where you get the degree from, but yeah. Unknown exception. You need to get a nice little, logo for yourself there. Yeah, and I'll follow. Programmer. What was I saying? Oh yeah. So 64-bit floats are fine because they're 64-bit, and everything that we're doing in the interpreter by default is 64-bit. Excuse me. And like I say, the format of a 32-bit float is not just a simplistic truncation, vice versa. So I'm going to need to handle those correctly. So the first thing I should check, excuse me, is make sure I'm even just outputting the right data definitions for those. I think I am. Yeah, that looks correct. Yeah, okay. Well, just tell them it was going to happen eventually, so. Excuse me. I don't know. Is there a shortcut? You gotta have your rubber ducky. Yeah, so Slayer Darth says, I don't like it when you see CS degrees offered by low-tier universities where they just teach you web development. Here's the challenge, right? I've mentioned this before. You can view education, I guess, in one of two ways. You can view it as the educational experience, right? You're going there. Again, if I think we were to look up the definition of university and we were to look up, years of history that the culture, right, of the academy, I think we would all walk away with the understanding that, going to university was not about job training. It was not about guaranteeing you employment of anything, right? Unless, of course, you were going to work in academy itself, but even then, right? Let's set that aside. I don't think that the intention was, with the exception of perhaps med school, but those are all postgraduate things anyway, right? So if we just talk about undergrads, this whole notion of going to college, university, because that gets you a job, that's a very recent thing, right? It's certainly within my lifetime, I think. If I were to try to pin it down, I probably would say, again, the late 1980s, the early 1990s was kind of when I started hearing that sort of talk all the time. But, obviously it's flawed, right? Some of us, like me, said it was flawed when I was hearing it, but, here we are all these years later, and it's clearly flawed, right? I saw a statistic. I'm not trying to find where sometimes I bookmark things, sometimes I don't. But I saw a statistic the other day that just blew my mind. It's only 20% of STEM graduates, so it's not just computer science, and perhaps, some of the other fields pull computer science down, but only 20% actually get employment using the skills that they studied in university. That's a shockingly low number, in my opinion, especially for what it all costs. So that's, again, on the purest side of things, you could look at it and say that having a diploma mill or having a low-end university that just teaches you web development so you can go get a job, that's perverting the intention of university education. That's perverting the intention of getting a CS degree. Okay. Then on the other side is everybody else who looks at it as this is just a thing that I have to do to be able to do this other thing. That's it, right? This is just in my way. I have to do it. What is the cheapest, quickest, most direct way of doing that? I don't care about the credential. I don't care where the credentials come from. I don't care that I learn anything. I'm not doing it to learn anything. I'm doing it because I need this stamp, because that stamp then will allow me to get a job. And you can't really blame people, right, in my opinion, for that stuff, because they're just behaving the way they think the game is meant to be played right now. I mean, yeah, it sucks. And especially considering the shortage of people in STEM, I don't know, man. It depends on what you mean by shortage and STEM. If you just take the current media, there's a shortage of people who have high advanced skills in math and science. I disagree with that. I think that's wrong. I have met so many people who are very good at math, have multiple degrees in math. I know several people who studied physics in university, did very well, could have continued, but didn't. Because there's no money in any of that, right? Like, it used to be that if you were really good in physics or really good in math, you would continue on, become a professor eventually, and do your own research. But because that whole, it's a pyramid scheme, right? Essentially, you can't have infinite growth there. There's too many people that are graduating in those areas. So there's no career path for any of them in academia. And, the career paths that you might have for some of those skill sets, in the commercial space are, maybe they appeal to you, maybe they don't, right? Like if you're really good at math, you could be a quant or an actuary. Look, again, if you heard me the first time, I said there are two ways of looking at this, right? There's the purest academic way of looking at it, and there's the current political media-driven, this is what you must do to get a job model. And I'm talking about the latter. I'm not talking about the former, right? If you're going to university if you are going to university today in 2018 or 2019, and you're doing it for the same reasons that someone in 1899 would have gone to university, fine, have fun. I don't have any problem with that, because your expectations are already aligned there. You know what you're doing, you know why you're going, right? But if you go to university today because you're going like someone from 2017 went, and 2016 and 2015 because got to get a job, well, that's a problem, right? Because I think that the messages there are very, very muddied and not accurate. And it would just, again, this all comes back to if people would just be honest, right? So we have a STEM shortage. right? That has nothing to do with university. I'm not knocking. It is what it is. But this whole media message that everybody go into STEM, everybody go into STEM, everybody go into STEM, you're going to get a great career, you're going to make big bucks. That's a lie. Now, it's not the university necessarily lying, although they could be more forthcoming, right, about the reality of that stuff, right? But of course, why would they do that? Why would they shoot, you know, the gift horse, so to speak? Sure, again, like I said, if you're going to go to university because you're going to go to university for the same reason that someone would go to university in 1899, you're fine, right? Because you know, the person who's going to university in 1899 isn't expecting to get a job. They're the only thing they're expecting to get is educated, right? And perhaps they get to meet people. That's it. That's all their expectations are, right? Well, if someone today goes to university for the same reasons, expand your horizons, learn more, meet people, great. I mean, if you have the money and the means, you do that because, you know, again, the expectations aren't skewed. But there's a lot of people that aren't, that's not why they go, right? They go because their guidance counselor tells them they have to or they're a loser. Their parents tell them they have to go or they're a loser, you know. And then they read all the media, and the media makes it sound like if you don't go, you know, you're a loser, basically. And that's a lot of peer pressure. That's a lot of peer pressure for somebody. And not only that, but then the poor young person, at least here in the United States, is then making financial decisions that are going to cripple them for the rest of their life. So, spreading stupid ideas to people's subconscious. Yeah. So sad. All right, how am I going to do this? My brain's not working very well. Gotta do my Winnie the Pooh. Think, think, think. Think, think, think. My son used to love Winnie the Pooh. Ugh. Well, today I am trying to fix bugs. I have one small bug in the interpreter, and I'm sure there's an answer that's just staring me right in the face. I'm not seeing it. But the issue is, 32-bit floating point and 64-bit floating point, they're both the same floating point standard, but because of the nature of the floating point encoding, the bits have special meaning. More bits have more special meaning, and so you know, going from 64-bit to 32-bit is not just a simple, you know, widening, just shifting bits over or whatever. There's actually some conversion that has to take place. And so all the other things that I'm doing in Interpreter are kind of focused around that 64-bit integer size for registers, which works for everything, including 64-bit floating point. It just doesn't, the 32-bit floating point, I need to have some way of funking between that and the 64-bit, kind of, not implicitly, but in the cases where necessary, things are being handled properly. Otherwise, you get, for 32-bit floats, you get weird values, is really what it comes down to. So there's a bug, you know, in the interpreter related to that. And honestly, I mean, I probably maybe can address the entire thing in this one function, set target operand value, but maybe not. I don't know. Because when I get down here, I know no, I'm not passing the type, because by the time I call this, I'm stripping the type out. Oh my gosh, I can't type today. Oof. So first, let's pass the type in here. I've always lived in my office because my office is my bedroom. I can't, typically I deflate my bed and I put it away before I stream. And it's not just for streaming. I usually deflate it because then it opens up the room and I have more room for stuff. I only need the bed while I'm sleeping. Oh, wow. Thank you, Duck of Doom. Appreciate it. But yeah, we had some electrical thing that blew the control unit on my bed, so I can't really deflate it. I mean, I can deflate it. I don't want to deflate it because then reinflating it is going to take me forever. I ordered a replacement bed, but it's stuck in customs. It should be here today, I hope. But yeah, this is my room, so let's see. Now, did two's complement make sense to you, Dr. Robot? Hopefully it did. Good. All right, so hey, Kubisus. Let's try. We need to. That's awesome. I'm glad I'm somewhat helpful. All right. let's go back to our short test script here. All right. We already know what goes on. But what I'm going to do is that. Okay. Because I want to hit this. My compiler will be faster. Excuse me. No, I forgot to turn my lights on. Oops. Okay, so this is the integer representation of that floating point value. Yeah, BCD is actually really clever. It's pretty clever. It's not, yeah, it's interesting how outside of like the mainframe and HP had some stuff, that stuff really didn't catch on too much. But yeah, that's not right. So the question is why? Because oh, well, actually, excuse me. I might know part of the problem. Maybe. Oh my God, I can't type today. Encode. So I don't know if anybody on the stream listening has ever used something like protobuf or Captain Proto. I actually prefer Captain Proto myself, but see stuff like this raw binary encoding, like Captain Proto does this perfectly, and you get this nice API on the front of it. But how does Captain Proto work? Well, Captain Proto works by taking an IDL and code generating something. And so, like, I'm really chomping at the bit. I can do the same thing with the metaprogramming in Basecode, and it's all there. I don't need anything extra. So it's little things like that. And then you're not paying any penalty, right? Like Captain Proto, the whole idea is, yeah, you're getting this nice API, but that API is built on top of, raw pointer access, essentially. Right, okay, so Because it is a float. Okay, so maybe we're not hitting here properly? No, we are. So, oh, shite. Scheiße. He's in the wrong damn field. Oh, Jeff. Okay, that might fix part of it. Constants weren't being encoded correctly. Oh. Donut. All right. That looks better, but I need to put my breakpoint back. Because we should be able to tell right away if that fixed part of it. Okay. No. That doesn't look right. Better, but not right. Because it should be 2.718, blah, blah, blah. Why? Okay. Get operand value. So we should hit this because the move has a constant encoded value, which is in the operand. So, yeah, that doesn't look right. Okay, so somehow I'm mucking up the encoding. All right. Code. Excuse me. Oh, I bet I know. Okay, so I bet F is wrong here at this point in operands. We're on what? I is 1. Yep. 2.718. Yeah, because our encoding in instruction block is busted. So we're doing a move constant to reg. Right, and this is the double overload. Okay, so what we have to say here is if size equals op size is dword, then this is going to be that. Right, because again, unlike an integer, right, I can't just assign the 32-bit to the 64. It just, well, I can, but yeah, it doesn't, it's not reversible, right? It's just, it's a shame, but it's not. Okay, so let's put a breakpoint here and set zone value. And it should be correct now. Thankfully, there are only two sizes for floating points. So, okay. So let's look at operands, one, value, yes, boom. That looks correct. See how the float is right, but the double's wrong? So this just shows you how they're not directly interchangeable. They have to be converted from one to the other. Unlike integers, where we could go up and down all the different types of integers, and they can all be, it's just a bucket of bits, and they can all be set cleanly. All right, so here we are. What was value? Value is that nice big integer. And the word, crap. Keyword float is still not right. Why? But it's 2.14, it converted it to an integer. Huh? Oh, no. I'm confused. Because that should have aliased properly. Unless, okay, there's something else wrong, which could be. Oh, well, I fixed one side, but probably not the other, right? Yeah. Well, there's one problem. All right, let's try that. Helps if the decode does the same thing as the encode in reverse. Okay. Yay! That fixed that problem. Okay, so that's good. So now we're getting closer. So now if I create a 64-bit float and I assign the 32-bit float to it, well, first off, that should be an error without a cast. Which it is not. That's interesting. Why? I've had to fix a couple small numeric type. I've had to fix a couple small type checking errors in the logic here. Interesting. Okay. Yeah, is that true? All right, so let's look at this again. We passed the type check on the type system. There's a method on element, or on type, I think. On type. Do I put it on element? I think I put it on element, called type check. And then so you can override on type check in subclasses. The other type gets passed in. So we try to in this case, we try to cast the other side to a numeric type. If that fails, obviously we're done. We compare the names of ourselves to the other type. If they match, we're good. So if we have F64 on the left and F64 on the right, it's the same type, no need to do anything else. Otherwise, we get the number class on the right-hand side. If it's floating point, and we're floating point, then I'm saying if the right-hand side is less than, in size and bytes, than the right. In other words, if the thing that we're moving into the left is smaller, then we just allow that. But that's not going to work with floats. So really, here, because if the names don't match, then, and the other side's float and we're float, then we're done. So that should error out. Mr. Anderson. Okay. Yeah. All right. So now, if I cast this to an F64, that should get past the type error. And it should emit a convert instruction to do the actual cast, which it did. Okay. So here's where we set E to that value, and we already debugged this, so we know that this is coming through now from encoding to decoding of the opcode. And then the store and the load, I don't think were ever an issue, right? It was always just getting the initial bits in there correctly. So we're gonna update E2, we're gonna get the value from E. So we load E, which is a float, so that goes into F1. So then we're gonna cast F32 to F64. So that emits a convert opcode, which takes, this is the destination, this is the source value, which is correct, because that's what we're loading. So this has a 32-bit pattern in it that is the float for E, and we're going to convert that to a double. So let's go back to terp and convert. So the target type is floating point, and the source type is floating point. So it's actually this one, right? Because we're going to a floating point, and we're coming from a 32-bit value to a 64-bit value. So this is the case we should end up in. And here, the interpreter is relying on the C++ compiler / runtime to do the proper IEEE conversion. When we rewrite this, I'm gonna have to build all that myself. That's okay. All right, so casted value, it's a floating point, and D is now the value. This is perfect. It's exactly, because notice the float now is non-interpretable, but the 64-bit integer value, the bit mask, is fine. That's what we want. And so then we're gonna update that, and away we go. So that's actually perfect. So fix the issue with how the 32-bit floats were being encoded and decoded. That was just a goof on my part. And so that looks good. And convert is seamlessly taking the float, 32-bit float, and converting it to a double, and the bit mask looks correct, and that's going into memory. Okay, now let's go the other way. Which this should be fine too, but let's just double check. So let's do E3. Oh no, E3, I gotta do a demo. Work 23.5 hours, slave, need a demo. All right, so we're gonna start with a 32-bit float. We're gonna upcast to a 64-bit float. Then we're gonna downcast back to a 32-bit float. And each time, the value we're gonna lose a little precision. So we're gonna end up here. All right, so here's the first. We're going from a 32-bit to a 64-bit. Now we're going from a 64-bit to a 32-bit. And yes, there it is. But you notice, we're gonna go slowly keep losing precision if we keep doing that, but now we're not doing any rounding. So you need to think about that. But you'll notice here, I'm doing the explicit cast because the compiler needs it. Here, I don't need an explicit cast because they'll just recast this for me implicitly. But there you go. So float to float is fixed. Those are working. Those are generating the right code using the convert instruction. So now we just need to test the integer scenario in both directions. So let's do IE, make it a U32, no, S32. And let's first try to just assign E to it. That should be an immediate dismissal, but we'll see. Yeah, okay. Now, let's cast that to an S32. This should end up here, because this is our target type. We're coming from a floating point. We're actually coming from a 32-bit floating point. So, yeah, so here we just want to cast it. Again, I'm not doing any rounding. I probably want to do rounding here, but come back for the rounding. Yeah, 2. So that's correct. Okay, good. Good. So let's do IE2, S64, 2, cast, S64, from E2. So this should be 2. And this should be 2. Yep. All right. Now we just need to do integers to floats, which I don't think are going to cause us too many problems. So actually, let's do this. Can I assign IE to that? Should not be able to without a cast. Yep. Okay. Okay, so this is going to be, excuse me, target is floating point, the source is an integer. Okay, so value is 2. We're going to cast that to a float, 32-bit. So now, yep, we have 2 as a float. And very nice. Let's do cast. Shouldn't matter. Right, there's that one, and D. Yep, perfect. Woohoo! All right, so minus the rounding, I think all of our casting cases work now. Very nice. All right, I'm going to take these out. Let's do so what I want to do is interp I want to put a breakpoint and store.
Well, you did it. Congratulations. You're on your way to looking and feeling fit, firm, and better than ever. Take care. Don't quit.
Okay, so this should be the first store to the E constant. So data here is 2.79. Okay, this is the second. That does not look right. Okay, somehow I knew that was broken. Because that should be 2 point, just copy it. Come on. Should be 8.154. What do I have? No, not even close. Okay, so let's look at the code that was generated. Oh crap, run it all the way through. Got to run it all the way through so I can get the disassembly. No, disassemble number 5. I want to buy one. I want to find a nice replica toy of Johnny 5. All right, so we're going to store it in E2. We load E. get the value, we load the constant that we're multiplying it by, and we multiply e times 3, put it in F0, store it. All right, so the code that's generated looks fine. So now let's go to multiply. Ah. Yeah. Oops. Yeah, so that's an interesting problem. Okay, so the first one is just the initial assignment. I'm going to skip over it. This should be after the multiply. Ooh, but it's 0. That's interesting. Okay, so let's look what we got. Okay, so we get the value of e. We move the constant 3 into I2, but it's an integer. So we need to cast it. So we take I2, we cast it to an F32, put it in F2, and we multiply F1 times F2, and that goes in F0. So now, okay, let's go right here. Ah, I see the problem already. Yeah, I see the problem already. Don't even need to deboogerate it. I know what the problem is. Because I'm silly. Which, that means all the math stuff I need to fix for floats, because they all have that same flaw. But we'll get this one working. Oh, forgot to put breakpoints. Okay, first one, now we're doing the multiply. Both sides are float, it's a D word. So we're multiplying 32 bits by 32 bits. So product result, ooh, the type is off. That's not good. The value is correct, the type is not right. Why is the type not right? Because I'm not setting it. Yeah, register type T, floating point. Integer. All right. Perfect. Correct type, correct value. All right, that fixes multiply. So we got to do the same thing for add. So if no. Okay, got inc, dec, add, multiply, gotta do sub. Okay. Mul did that. Div, gotta do div. Div is very important. Because of divide by 0, which I prohibit. If you divide by 0, you get 0. I pre-initialize the type on this one. So if we fall into the floating point scenario, if it's a 6 or 32-bit value, if it's not 0, we do the divide. Otherwise, if it's 64-bit, if it's not 0, we do the divide. Then integer, not 0, we do it. Yeah, and the value is already assigned to 0. Mod, don't need to do anything. Shift right, shift left, rotate right, rotate left. Those are all and or XOR not. These are all just integer operations. Yeah. Hey, Soding. How's it going? Okay. Let's do multiply that by 3. Let's add 1.105. I am writing a compiler for a new programming language I'm designing called Basecode. And then let's divide this by 2. All right, so let's look at the code it generated. This is the initial assignment, getting the address of our target, getting the address of our one variable in the expression, getting the value, moving a constant of 3, which needs to be casted because it's not a float constant, it's an integer constant. We do the conversion, do the multiply. So this is e times 3. Then we have a float constant. So we move that into F4 and we do the add. So the result of the multiply gets added to that constant. And then we have our second constant here, which is a float. We divide the result of that add by 2, and then we store it. So that looks correct. And let me go to store. It will produce, so out of the gate, my targets are going to be x86, 64, i686, whichever designation you want to use. ARM 64-bit and WebAssembly. If at some point, I mean, I'm sure there's going to be a ton of other targets that I'm going to want to support. So, thank you. That doesn't look great. Uh-oh. So something is off. Somehow it, okay, which one of these burped? So I guess let's look at add. Oh, I love assembly language too. I don't know if if you go to my YouTube channel, I have a whole ARM 64 and old-fashioned x86 assembly series. Oh, I'm so silly. I'm so silly. Did I make that mistake other places? Probably. FFF, DDD. Nope, looks like just that one spot. Okay. That wasn't too bad. Okay, the survey says 4629928.7, so let's check that. Oops. Plus 1 point, crap, I forgot what the other one was. Was it 1.15? For 1.105. Come on, you can do it. What? Four dot 6299. Yep, it's right. Okay. All right. I'm going to take a really short break. When I come back, we'll do more. It'll be awesome. I'll be right back. Hopefully, OBS still allows me to do this.
The hardest part.
Okay, I'm back. All right. So the only question I've got here is, so obviously if you write a, float literal, then you wouldn't need the cast. Oh, cool. Thank you. Yeah, so I don't know. I guess I'm gonna have to track a question on that. Do I want to force you to have to cast an integer literal like that, or can the compiler just deal with it? But that very softly violates my no implicit casting rules, so I'm not really sure. If it's a variable, yeah, you gotta cast it. But if it's a constant like this, if it's a literal like this, I don't know. I think about that. And I guess while we're playing with this, let's make sure that the 64-bit version works. It should. Interesting. Oh, yeah. I bet we're going to get the same error on the other side, or on the E2 expression. No? All right. That doesn't look right. Good thing I decided to test that, huh? Why? Oh, because I fixed the type checker. That's why. Because I'm being more firm in terms of assigning 64 and 32-bit floats to each other, which means, yeah, this. Yeah. Shit. That's ugly as shit. Because what was happening is these are F32s, because they fit in an F32. Let's say you had part of the expression that was F64, and you had part of the expression was F32. Now, see the binary operator stuff? Like, the type checking is not correct there. It's just really simplistic. So what probably should be happening in some of these cases, like with the binary assignment, if it's a literal, right, what should be happening is the binary operator should just say, oh, all right, the right-hand side is a literal. It is a compatible floating point number, just widen it, right? So the type here would report as, the type inference system would say this is an F32, which is what it is. It fits in that. But the binary operator should then widen it and say, yeah, that'll fit in this. I'll let that go. Now again, variable to variable, that's different because you're not sure exactly what the programmer's intent there is. So I think forcing a cast in that situation makes sense. But like this would be the same thing. What should be happening here is type inference for this entire expression should be saying, okay, the largest type is F64 here. Widen all the constants to F64 so that you don't have to. Now, obviously, this one's an integer. It needs an explicit cast. Yeah. So as long as they're the right size, it works. It's when they're not the right size, it doesn't work. But then, oops, this brings up another thing that I'm thinking about here. Yeah, stacks are beautiful, especially in assembly language. I don't know, they're just so simple. So the other thought that occurred to me here, maybe this is generating extra instruction. I mean, the convert instruction is just, it's a cast. Although I was looking at what the C compiler generates to convert to floating point, and it's not always the most efficient thing. There are some efficient workarounds for some of that. You know, setting that aside, in this case, when they're literals, like, so example, well, first off, these should be widening. So I'm not even going to worry about those. That we should just fix in binary operator. But like this case, where we do have to cast it, but it's a literal. So, you know, then you say, okay, well, how often does that happen? I don't know. Because what you could do here is, in this case, the cast could actually be like a fold, where the cast could actually say, well, I'm just going to tell you that this is, I'm going to replace this so that it's a float literal with a 3 in it instead of an integer literal with a 3 in it. In this particular, you know, like, so the cast would be returning a new element in that scenario. Because we don't really need to emit the convert instruction there. We can get the same thing by just telling the compiler, hey, it's a float literal here. Okay. So let me review this. So I switched over to the short bus to test this because I had bugs, and so I put my football helmet on and rammed the back of the bus while I was fixing these. So I just set up a I started with a 32-bit float constant, went to a 64-bit just to test, and I fixed, I think, all of the underlying interpreter issues with 32-bit versus 64-bit floats. I'm sure there's maybe a couple of small stragglers I missed, but I think I got most of it. I fixed an issue with the type checking because I was allowing implicit conversion from 32 to 64-bit float, which is kind of bad. For integers, that's tolerable, but for floats, that actually requires active translation, which I was not doing. So in the terp header file, I added the type to the set zoned value. Now it turns out I don't think I actually needed that, but I'm going to leave it there for now. I might eventually take it out again because I might need it. I don't know. It's not hurting anything at the moment. So there are a couple of bugs. Ironically, in really old code, the instruction decode and encode functions were not handling 32-bit floating point values correctly. I was not assigning them to the correct field in the union, so they were getting all butchered. They were being interpreted as doubles, which was bad. So I fixed that. So the encoder and the decoder now for the instructions handles that correctly. So that was one problem. The next problem is that in all of the arithmetic operations that can manipulate floating point numbers, I need to make a distinction between 32-bit and 64-bit floats, which I was not doing because I have to operate on the correct field in the union to alias those bits properly. Otherwise, you get garbage. Also, I was not setting the type on the operand value that I was creating in these situations, so that was bad. So I fixed the increment instruction, the decrement instruction, the add instruction, the subtract instruction, the mul instruction, the div instruction, and the negate. Those all now handle 32 and 64-bit floats properly, and they set the types on the structures properly. So the tagged union is actually a properly tagged union. And then I passed the type along to set zone value. And I'm not using it, but I'm passing it. I have a feeling I'm going to probably need it at some point in here, but we'll see. So those were the changes to the interpreter. Not too bad, better than I thought. In numeric type for the type check overload, and now I'm wondering, yeah. So I was saying that if both sides of if the left-hand side type and the right-hand side type were both floating point and the right-hand side was smaller than the left-hand side, then that was okay. That was type checking out. But that's not really, again, like with integers, you can kind of get away with that. But with floats, you can't. At least the way I'm, maybe when we rewrite the compiler and I have my own IEEE 754 or whatever I use for floats, once I have my own library functions for all that, maybe some of this stuff could be a bit more seamless. But here I kind of have to make a hard distinction because I'm aliasing the bits through a union. So I have to pick the right field. And then an instruction block are make move instruction for the double value. So this is destination register constant floating point value. So again, inside of the code, all the floating point values are referred to as doubles. That's kind of our interface. But at the terp level, I have to make a distinction between, well, this is actually a 32-bit float. This is actually a 64-bit float. I have to set the right field on the union. So I fixed that. And that was the last piece related to the the floating point aliasing issues. Yeah. So that's good. Wunderbar. So now pop stuff off the stack. What's left for casting? So first, with integers, I'm realizing I needed to have these distinct types because I'm emitting different instructions. But for floats, floats to floats, floats to integers, integers to floats, it's all the same instruction. So I can do this for sure, right? Then the question is, do I really need to, then do I need to have as many modes? Probably not. Because these all just become the same opcode. Yeah. I mean, it's not really hurting anything to have the variation here. I'm just trying to think, like, I mean, I think this is essentially a no-op. I mean, it's not a no-op. There is a cast happening, but it's a widening. This is going to have a round on it of some kind. This is going to have a round on it, and so is this. But the round is just, I'm going to pick round to 0, or I don't even know what I said. Right? I just said rounded. Right, so casting float to integer would round towards 0. Casting from a larger float to a smaller float would round probably, again, towards 0, I would assume. Integer to float would round up, probably. So that's really all that's missing are the rounds. And those would go in here. And then the only other issue would be handling man and inf for integers. I mean, I'm assuming I would just make those 0, but I'm not sure. So I'm thinking again, I'm not considering any of these, like, these issues don't represent like the final end all state for these things. These are just, you know, round 1, round 2, round whatever. I'm probably gonna have to revisit these. Definitely gonna have to revisit them. But I'm kind of thinking that, you know, for the numeric casts, we could probably consider them done for now. Good enough to allow us to get to the next part, right? So what were the things that came out of this? So I need what's our okay. Okay, so there's that issue captured. What else did we have? Okay, yeah. Should numeric literals implicitly type convert? For example, foo 32 equal 3 times 6. Should the compiler convert this term to Okay, so that was another one. What else? Was there anything else? Oh, gotta change the battery. One sec. I really wish my power pack would get here. Okay. All right. What else? Was there anything else? I keep thinking I'm missing something. I don't think so, but I think those were the most important. All right, so let's wrap up cast. So I think I just made some notes here and consolidated this down. All right, that wraps up cast. All right, so now I gotta think about what's next. So I think what really has to happen next, I wanna fix the constant assignment stuff. So that's going to be adding the constant assignment operator, which right now I'm thinking is : equal, removing constant and alias as statements in the language. This one is super easy, really. It's just removing stuff. This one shouldn't be too bad, but yeah, I say that. So those two I would like to get done. But I think really to kind of go to the next stage of all this, I need to start working on composite types. So that goes there. I had something on here. Where'd it go? Well, yeah, we can put that there. Put this there. Ah, yeah, here it is. So it's just probably me, right? But it would be really cool if, this is why I love text files, right? Like I can just tab shit over. Like somehow, like these two are related to each other. I could tab that in. That's the one issue I have with tools like this, is that it doesn't quite give you all the, unless there's some magic key combination or something that lets me do that. Okay, so I think, like I say, the next step is going to be removing constant alias, adding the constant assignment operator. This is going to do what these do and more. Then the big question is, okay, I need to start getting some basic type information into the emitted code, because we're going to need this, because I need to start fixing things like any and all this other stuff. And of course, like this all the way down through tuple type, they kind of relate to each other, right? Because they're all sort of related to complex or composite types. Because once we can get composite types working, things like string, any, arrays, and of course, obviously, initializers and finalizers are really going to go hand in hand with those. And we can really start getting a lot of that stuff to work, but also I can fix the FFI implementation, because I'll actually have type information for things like any. Because right now, if I had a print, right, which is just going through printf ultimately, I can't mingle types right now because I don't have the information to do it properly. But the other cool thing is that we get composite types, initializers, all that stuff working. That means we would have, if we get the type stuff in there, we get any working properly, then that means that I could implement, maybe not optimally, but I could implement some form of a base code version of a print, right? That would be like the format library where it would be type safe. Okay. What sort of bug do you have? Goodbye, Big Juice Mane. Off with his head. I really hope, like, I really hope that these are just kids, you know, like 12 years old, 13 years old. They don't know any better. But I'm probably hoping too hard on that. Somehow I knew that it wasn't going to be a software bug. Okay. Yeah, running kind of short on time today. So instead of jumping into any new code at the moment, if you guys have any questions or topics for chat, I can probably gab for about 20 minutes or so. I'm afraid if I get into either of these, it's going to be... Yeah. Yeah. How am I doing? Yeah, I'm okay. Yeah, like I say, there's a lot of, the air quality hasn't been that good, which is a shame because usually it's excellent here. So, yeah, I'm the kind of guy, like, if I had to live in the, you know, the times before electricity where fire was what you had, I would have died years ago. If I sit next to a campfire or something, it's horrible. Like, the allergic reaction I have is just from the smoke. It's insane. Not to mention the horrible headaches that I get from it as well. So yeah, I mean, that's kind of sucked a little bit here recently. But yeah, otherwise, doing pretty good. It's weird because, and I have to tell myself this every day. I think everybody does this, you know. And I think I've mentioned this before too on the stream, but it's very difficult to gauge progress, especially your own progress. Because on the one hand, you know, I feel like I'm getting a lot done, and I'm happy with that. On the other hand, I think I'm going too slow. I want to get more done. And so it's just this constant tug of war of, well, I have to go through it in my head, like, could I be doing things faster? You know, maybe, but then it's, I don't know if you guys saw it, but DHH had a interesting Twitter exchange with some massive douchebag the other day, because massive douchebag evidently has a company and they were looking for developers, and the job posting literally said, you know, you have to guarantee us that you can devote, what was it, like 60 plus hours per week for 5 years straight, because, you know, we're going to be that busy, kind of a deal. And of course, DHH is a big promoter of sane working conditions and not burning out, and yeah, seeking rock star programmers, right? And so, yeah, of course I could, yeah, exactly. I could put on my, pointing hair boss hat and yell at myself and be like, work more, do more. But I know that's like, that isn't really an answer, because you just get temporary boosts. And even then, the boosts are illusory, right? Because yes, maybe you get through a particular list slightly faster, but in the back of my mind, like I said earlier, this is like, I know this is not the list. It's not the last list. This is the list I have right now. So when I get done with these 50 things, then I'm going to have another 50 things. And eventually, right, those will wind down to some kind of equilibrium, right, where I'll make a decision that it's good enough or whatever. But yeah, so, I think about that a lot. And what else? My interaction with clients has gotten more bizarre as the years gone on. I'm not really quite sure what to make of that. And then I see like this guy who is arguing with DHH in public, and yeah, and you want to think that that's an exception case, right? But I've had conversations of my own with people, and I think, wow, people are nuts. Yeah. I've thought about writing a book, which admittedly I think I've thought about every year of my life, my adult life. Although I certainly think I have more I could say now. I could probably structure a book, a nonfiction book, much more cogently now than I could have 20 years ago, 25 years ago. Thought about making a documentary film. Yeah, I'm very concerned for our industry. We're, and I've said this before, we're hamsters in a cage, and the wheel is, the Apple, Microsoft, IBM, Oracle, Google, whatever, treadmill, Facebook. We're driven by these fads in industry, and I think it's really hurting our industry. It's really hurting our industry. And I'm noticing a lot, because I follow more or less, I would say, the original group of Agile folks on Twitter. I don't really interact because I don't have anything like, quip worthy to say, but I have been kind of collating a lot of what I'm seeing, right? These folks talking about, and I basically see that the original Agile group, the folks that penned the Agile manifesto, they're more or less kind of walking away from Agile, sort of in a public way, because what has now become Agile is not what they intended. It's just some commercialized management, hell methodology, by and large. And so I see a lot of that going on, and I see a guy like Uncle Bob who's trying to push back into that space, and I think that's a bad play. I don't think that's going to work. I think the idea of software craftsmanship or some kind of professional standards, yep, Six Sigma, absolutely. I had a poop belt. No, I just, I see all these things going on, right? And a lot of what's going on, I think, are symptoms of, just an illness that the industry's had for a very long time. And so I don't know. I mean, of course, taking all these disparate thoughts and turning them into some kind of cogent narrative is tricky no matter what. But the thought has crossed my mind a number of times. But at the same time, going back to the earlier chat we had about, the shortage of workers in STEM, there's a lot of, I guess it just is what it is, right? It's propaganda. We got to call it what it is. And it's bullshit. And I'm so tired of hearing it. And, so I thought about making a documentary film. I mean, I know a lot of developers, and I know a lot of developers who are good developers. They don't work in the field anymore. They haven't worked in the field for years because they can't get work. And, I think there's a lot of reality that average folks are not seeing, right? And of course, it's always tricky. I don't consider myself partisan at all. I write in Beelzebub and Satan, for president because, last election I wrote in Cthulhu because if you're going to be subjugated by an evil demon, it might as well be a real one. So I'm not in any way, partisan. I think both parties in the United States are fucked up and evil and corrupt. But anytime you present these topics, right, it's so difficult to do because people just knee-jerk and they reflexively fall back to their tribal alignment, which, prevents conversation from happening. But yeah, I think there's a big story in the software development space that's really not I think if you were just walk in a big city in the US and ask them, do you think programmers are doing okay? I think most people would say, oh yeah, don't they make a lot of money? And what are they thinking about? They're thinking about people who work for the FANGs, right? But that's a very small percentage of, the population, right? The programmer population. Do you think that tech guys are overly cocky? Most of them I meet think that they have God's nuts in their grip, even though they don't. Well, so again, I think this is part of our. I think it's part of our larger issue in the industry, right? We're fad driven. I think in the last 10 to 15 years, a lot of these, unicorns, essentially fire pits where billionaires pour their cash and watch it burn. So I'm talking about Twitter and Netflix and Amazon and a lot of these other companies. I think these companies have kind of given the people who work for them, right, the wrong impression. And a lot of them are kids, right? So I can't really, Uber, I can't hold it against them per se. I think they've been led astray. So are there a lot of cocky assholes in software dev? Yeah, there are. Some of that is just, and this is very politically incorrect nowadays, right? But some of that is these kids need an adult to smack them in the ass or the face and say, stop being a shit, grow up. And nobody does that, right? And yes, and then so cache override hits, another big theme, right? Is you got to get them young and cocky and stupid so you can burn them out. And this is the story that I think isn't really, no one knows the story in the tech industry. Those of us who are in it know it, but I think the general population is not really aware of the fact that in some ways, right, there's cult-like behavior going on, and it's not healthy, it's not good, right? Absolutely, yeah. Well, and that's the other thing too, right? This whole mentality of, and I had recent conversations with some potential clients, right? That this whole notion that you need to love the company and the company is extended family. I mean, if I ever hear anybody start telling me that, we want you to be part of the family, I always interrupt them, right? And I always say, thank you, but I have a family. You're a client or you're an employer, right? You're not my family. We're not going to go down that road because that's mental manipulation, pure and simple, right? Well, and there are cultures like Japan, or I would say maybe South Korea, and there probably are others where, their whole culture, whether that's healthy or not, they're definitely more, they think more that way. But then at the same time, like if you're a Japanese salaryman, I mean, if you can tolerate that arrangement, they at least come through on their promise, right? As where, here, there's no chance of that. And I think, that's pretty true everywhere. But I think the distinction that I would make is the cult-like aspects of this caring thing are relatively new, right? Because I've been doing this for a long time, and it's hard to pinpoint exactly when I first started seeing it, but sometime in the mid to late aughts, the cult-like aspects of it, I think, started to really appear. I think there's always been, to some extent, depending on the company and the industry, I think there's always been some kind of loyalty thing going on there. But I think the loyalty of like old time, when I say old time, like let's say the 1930s to the 1970s, I think that was a slightly different kind of loyalty equation. That was probably closer to like the Japanese salaryman model, in my opinion, than what we have now, which is you have to pretend to fawn over your employer or your client or whatever, and you have to lie to them and tell them you care and that their vision's so important. And yes, right. Cache override, I think, hits on it, but and that's also, you use the verb to evangelize, and I think that's very interesting, right? Because to me, that's an attribute of a cult, right? And again, it's a lot of this is very difficult to dice, right? But it it's there, and I think it's getting worse, and it's very worrying in my opinion. So I think there's a lot of topics there that one could cover, but it's like anything, right? I have tons of ideas, and I work 6.5 hours a day, generally speaking, and usually I prefer to just write code during that time. So yeah, the evangelization, right? The I'm trying to think of a good example, but I don't know if any of you have seen that movie with that actress who played Hermione Granger. What's her name? Emma Watson? Is that her name? And Forrest Gump. What's his name? Tom Hanks. I didn't really like the movie overall, but I thought the weird, creepy vibe that that they had in that fictional Facebook duplicate was pretty good, right? And I thought that was. It's not a great movie. I'm not, but there were parts of it where when she's in the company and how they behave and this whole evangelization thing and literally giving your entire life over to this company, I thought they captured that fairly well. The plot's kind of retarded, and it's not a movie I would recommend in general, but they did nail the creepy part pretty well, I thought. And yeah, so there are a couple things out there that sort of capture part of it, but again, it's people would look at that and say, "Oh, that's fiction," but yeah, it's fiction based on some fairly stable, reality, unfortunately. But and then also, I think the core crux of the message that I would want to get across in anything that I would produce would be that, look, if we're all playing the game of market economics, then software developers are a market just like any other. But if you look at the interactions we're having and this whole evangelization and cult-like behavior, it doesn't fit in a market economy, and we're not seeing supply and demand laws operating properly. Why is that? There's just lots of things like this that I think you could present a lot of really interesting information that a lot of people may not realize. So yeah, that's been another set of ideas. I've thought about doing a podcast. I mean, a lot of people have mentioned podcasting. Every time I look into it, though, I don't know, somebody help me, right? Like, sometimes I can be really retarded. I look into it, and it's not, and maybe this is my laziness talking, right? But like with streaming, like I, just hop on Twitch, or I can hop on YouTube, and, it takes some effort, but it's relatively easy to get that set up. But with podcasting, it's like, I don't know, the plumbing, right, for how you actually distribute your thing seems to be very Rube Goldberg-like. And maybe that's because podcasting started with like RSS, and it was really more kind of like a federated / syndicated type thing, and there wasn't a centralized service that was really doing it. But like, how do you get, like I've looked at a bunch of blog posts and things, like how do you actually get a podcast on iTunes? And it's not super clear to me. Yeah. And then, the trick with podcasting, I think, is what's the format of your show, and what do you talk about? Do you have guests or not? And if you have guests, now granted, I haven't tried, so, maybe I would be surprised, but I got to think that like most popular speaking guests are getting a lot of requests. Most of them probably get paid. Unless they're shilling something, then you might be able to get them for free. But yeah, I always kind of get stuck in analysis paralysis on that one a little bit. I should pick a bunch of podcasts and try to consume them on a regular basis and see if what I think. Like I've what is it called? Chris Gamble, he's an electrical engineer. He has a podcast. I listen to his semi-regularly. A lot of the programming ones, I don't know. They don't really do much for me. not too impressed with a lot of them. So yeah, I've rolled that one around in my head a little. But all right. Yeah, I did see that because he was talking to Joe Rogan about it, right? I'll have to listen to his, see what I think. All right, guys. Any other questions, comments? See if we can find a victim here. Programming creature melee attacking behavior. Interesting. Wow. Graphics programming in Rust with Vulkan. I'm kind of waiting for Twitch to implement their change. They're going to get rid of communities. They're going to change their tagging. Honest Jazz and Code, working on unfinished features of my LD42 entry. Oh, who's this guy? Oh, Jessica's live. Game Maker. Cool. Oh, let's raid Jessica. See what she's up to. Okay. Say hi to Jess. Be nice. I'll be back online tomorrow, 5 a.m. And we will write more code. And yeah, should be good. Everybody take care, and I will see you tomorrow morning. Here we go. Bye.